Welcome to AP Podcast 15.4D. Finally, we get done. This is about titration curves, and for the most part, because of the titration podcast you've just seen, it's just kind of just a quick review with a couple new points. And so let's look at the one that occurs when we have a strong acid with a strong base. So imagine a strong acid and a strong base. You guys know basically that the reaction goes like this. We've got some H, right? And we've got some OH, and we make some water. Okay, so if you think about our product, the pH of water is at 7, and so that's where the equivalence point is, right there. And basically, what you have is a very low pH. This could be anywhere from 0 to 1, right in here. And it stays low, stays low, stays low, and then all of a sudden, when you get that equivalence point, zip, we get that dip right there, and the very next drop of strong base is going to cause it to shoot up and start going this way. All right, so that's pretty basic. Important point is that equivalence point is at 7. Now, if we look kind of at the opposite effect, a situation where we'll go ahead and do a strong base with a strong acid, we start up here, right? I mean, if you think about it, we're looking at the pH of our base, and we start dumping in some acid. And again, same situation. And again, we still have the same reaction. We've got some OH plus some H plus, gives us some water. So we get our pH of 7 right there. All right. Now let's move on to a weak acid with a strong base. Now you've seen this before, and again, the important thing to know about this one is the fact that you have equivalence of a pH that's greater than 7. All right, and the thing to remember why that is, if you think about what's going on, we've got this weak acid, right, and we're adding some OH, and we're generating, of course, some water and some of the anion, okay? And so that anion right there, when it is further in water, will grab one of those H's, making some HA and some OH minus, right? So even though all the original acid is gone, that pH is going to be above 7 right there, because what's left when you have neutralized all that acid? The next thing I want to show you is a question that pops up. Well, it pops up in our textbook. I've seen it on various AP tests, and it's just to make sure you've got an understanding of what this graph means. So you might see something like this. We've got this weak acid, strong base titration curve, and they want you to list where the following things are. So look at that for a second, and if you want, pause the video, put A through F there, and see if you get it right. Okay, let's see how you did. First of all, the stoichiometric equivalence point. Well, we know that's right here, so A would be right here. And again, it's going to be greater than 7, right? Because this is a weak acid with a strong base. So there's A. The region of maximum buffering. Well, right in here, from about there to there, we're getting a lot of buffering because we've got both the acid present and it's salt, or the anion of that acid present. So we get a lot of buffering right in there. Where does the pH equal to pKa? Well, if you think about Henderson-Hasselbalch, right? pKa plus the log of the anion over the acid, right? If we think about this, when this value right here is 1, in other words, let's say I've got 1 molar there, 1 molar there. Well, what's the log of 1 equals 0, right? Okay, the log of 1 equals 0, so that the pH will then equal the pKa, and that's smack in the middle here. So right here, I'm going to put the letter C. All right? The pH depends only on the acid concentration. Well, that's going to be right here. That would be right at that pH. The pH only depends on the anion present. Well, that's really right here at the equivalence point, right? However, if you wrote anywhere, basically from there to there, it would be fine. Okay? And then the pH depends only on the excess base. So that's anywhere right in here, right? All that excess base. So there you have it. That's a common question, for whatever reason, kind of pops up every so often. Okay, and then our last one is when we have a weak base and a strong acid. And again, because we're starting with a base, right, our pH is started up here pretty high, and we're adding our base. We've got some buffering, buffering, buffering. Then you get that equivalence point, and notice it's below 7. And again, for the same reason, if you think about what's happening, we've got a weak base. We add some H plus, right? We make some NH4 plus, right? And once all this is gone, once we've gotten rid of all that, look what we have floating around. Now we've got ammonium floating around. And what's it going to do? It's going to give off a hydrogen. All right? And so even though we're at the equivalence point, even though we've used up the same amount of base and original strong acid, now we have this floating around, and since that's going to disassociate, making an acidic environment, this pH is going to be lower than 7. All right, that's a really important point because it's a great question for them to ask you on a test. All right, then to summarize everything, the nice thing about strong acids and strong bases is it's all about just stoichiometry, right? That's all it is. So it's just a stoichiometry. When we have a weak acid, and again, it's the same thing for a weak base, we do the stoichiometry, then we do the HH equation, and then all we've got is leftover strong base. And again, this is good notes to have, but it's something that hopefully you know what to do. If I give you a problem, you just know these steps. And then here comes the same thing if we've got a weak base, stoichiometry first, Henderson-Hasselbalch, same thing as last time. Okay, so that's just kind of a summary of our titration curves, a summary of what to do with these. These are the most involved chemical situations that we deal with all year. I like to look at them as a nice big puzzle. They're kind of fun, especially when you find out that you've worked it all out and you get the right answer. And so, like always, if there are any questions, I'll see you in class. And hopefully this all made sense. See you next time.